During office hours, I had a few people ask about question 1 as well, determining how many lone pair electrons are present within each molecule. So to do this, we have to make the Lewis structure for each of these molecules. And so for the first one, I've got carbon, I've got hydrogen, and I've got sulfur. Right? I do the electron configuration of carbon, helium, 2s2, 2p2. Hydrogen is 1s1, and sulfur is neon, 3s2, 3p4. So I have 2 carbons, right? I have 6 hydrogens and 1 sulfur. So I have 8 electrons here. I've got 6 electrons from hydrogen, and I have 6 electrons from sulfur. So that's 6 and 6 is 12, plus 8 more is 20 electrons to assign. Going to place sulfur in the middle, carbon, carbon. And those hydrogens are attached to each carbon. So I've got 3 hydrogens attached to each carbon. All right, so I had 20 electrons. I just assigned 2, 4, 6, 8, 10, 12, 14, 16. So I just assigned 16 electrons. I've got 4 electrons remaining. Right, if we take a look, sulfur is currently violating the octet rule, right? Sulfur wants to have 8 electrons in its outer shell, so I'm going to take and assign those 4 remaining electrons to sulfur. So how many lone pairs do we have, right? I have 2 lone pairs of electrons, right? And they're both on sulfur. If we take a look at the cyanide example, HCN. So hydrogen is 1s1, carbon is, again, helium, 2s2, 2p2, and nitrogen is helium, 2s2, 2p3. So 1 electron from hydrogen, 4 electrons from carbon, 5 electrons from nitrogen, 10 electrons to assign. Carbon, nitrogen, and hydrogen. 1, 2. So I just assigned 8 electrons, right? I've got 10, I assigned 8. I've got 2 more electrons to assign. I need to fill the octet of nitrogen. Nitrogen only has 6 electrons drawn on it, so I add 2 lone pair electrons to nitrogen. That fills the octet for nitrogen, and that creates 1 lone pair of electrons. Right, ethylene is pretty straightforward. Ethylene, the structure of ethylene would look like this. Carbon double bonded to a carbon, hydrogen, hydrogen, right? And we would have 0 lone pairs of electrons. And then the last example, carbon, hydrogen, 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 and my fluorine. And the lone pair electrons of fluorine, right? I have to fill the octet of fluorine, 1, 2, 3, 4, 5, and 6. So I'd have 3 lone pairs of electrons on that fluorine and 3 lone pairs of electrons in that molecule.